Hey guys, so today we're going to solve systems of equations with elimination. This is my absolute favorite way to solve systems because I think it's really cool the way it works out. So hopefully you guys think the same as you guys go through the video. Again, if there is anything that you don't understand while I'm teaching it, please Google. There are so many resources out there about how to do this online. It really would be smart of you to research this a little bit more on your own if this is something you're struggling with. So solving a system by adding equations. So first you're going to eliminate one variable. So I'm going to rewrite this system. It's 2x plus 5y equals 17 and 6x minus 5y equals negative 9. So the first thing we're going to do is we're going to look like we're adding. So 2x plus 6x is 8x. 5y minus 5y cancels out, and this is why it's called elimination. 5y minus 5y, they cancel out. We eliminate the variable. So we do 17 minus 9, which is 8. And now we're going to solve for x. So we divide by 8, and x equals 1. So again, I could do that because 5y and negative 5y are equal but opposite. They're both 5, but one's positive, one's negative. They cancel out. So now that we know what x is, we're going to substitute that back into both equations and solve for y. So this is very similar to substitution. Once you find one variable, you're going to find the other. 2 times 1 is 2 plus 5y equals 17. Subtract 2 on both sides. You get 5y equal to 15. Divide by 5. Y equals 3. Let's make sure we get that in the other equation as well. 6 times 1 is 6 minus 5y equals negative 9. Subtract 6. You get negative 5y. These are the same sign, so we're going to add them, keep the sign. Negative 15, divide by negative 5, and y equals 3. We check out. Now, the last step is you're going to write your solution as a solution set. So it becomes your x, which is 1, and your y, which is 3. Again, you can always double check this by graphing, but your check is right here when you plug it into both equations and it comes out okay. You really want to make sure that you become well-versed with at least doing one of these. Again, this is my favorite way because I think it's really interesting. All right, looking at the next one. So do we have any variables that are equal and opposite? Well, this is a 5 and 3. They're not equal. 6 and 6. They're equal and they're opposite. One's negative, one's positive. So these are going to cancel out. And what we have left is 5x plus 3x. We're adding them because they're both positive. And negative 32 plus 48, which is 16, because it's the same as 48 minus 32. Divide both sides by 8, and I get that x equals 2. So now I'm going to plug 2 back into both equations. 5 times 2 minus 6y equals negative 32. And 3 times 2 plus 6y is equal to 48. 5 times 2 is 10 minus 6y equals negative 32. Subtract 10, and I get negative 6y equals negative 42. They're the same sign. Both are negative. The 32 and the 10 are both negative, so you add them and keep the sign. Then we're going to divide by negative 6, and y equals 7, because a negative over negative is a positive, and 42 divided by 6 is 7. Over here, 3 times 2 is 6, plus 6y equals 48. Subtract 6 on both sides. 6y equals 42. Divide by 6, y equals 7. It checks out. So now we write our equation, or not our equation, our point, which is 2, 7. Again, x and then y. Okay, over here, is there anything that's equal and opposite? Well, the x's are equal and opposite. They're both 3's, one positive, one's negative. So they cancel out. Now we add negative 3y plus negative 4y is negative 7y. 9 plus 5 is 14. Divide by negative 7 because we're trying to get y by itself. And I get y equal to negative 2 because 14 divided by negative 7 is negative 2. Now I'm going to plug negative 2 back in for y. So negative 3x minus 3 times negative 2 equals 9. I'm going to write the other equation in a second because there's not really room over here. So negative 3 times negative 2 is a positive 6, so plus 6. We're going to subtract 6 on both sides. because it's a positive 6, and I get negative 3x equals 3 divided by negative 3, and x equals negative 1. Let's check if we get that in the other equation as well. 3x minus 4 times negative 2 is equal to 5. Negative 4 times negative 2 is a positive 8. Subtract 8 on both sides, and I get 3x equal to negative 3 divided by 3, and x equals negative 1. This checks out. We're going to write our point, our solution, which is negative 1, negative 2, because negative 2 is our y. And that is our answer. I should box these for you guys. Okay. Now, what happens when you don't have something that's equal and opposite? So when you don't have something that's equal and opposite, you need to multiply one or both equations to make them equal and opposite. So here this step, we're just multiplying one equation. 2 and 7, you can't really multiply one of these to get equal and opposite. But 15 and 5 is a factor of 15, so we can do that. We can multiply this whole bottom equation by 3. Because 3 times negative 5 is negative 15. Negative 15 and 15 are equal and opposite. So if I do that, 3 times 7 is 21x. 3 times negative 5 is negative 15y equals, and we have to do 3 times 17 as well. 3 times 17 is 51. 34 plus 17 is 51. And then I'm going to rewrite this top one, so it's negative 2x plus 15y is equal to negative 32. So now we're going to solve it just like we did before. The 15s cancel out. 21 minus 2 is 19x. 51 minus 32 is 19. Divide by 19, and x is equal to 1. So now we're going to plug 1 into both equations to solve for y. So negative 2 times 1 plus 15y is equal to negative 32. And 7 times 1 minus 5y is equal to 17. And we're going to plug them into the original equations. Don't do the equation you made, because if you made a mistake, then your answer might still come out as correct. But this allows you to check in the original equation. So always use the original equations. Negative 2 times 1 is negative 2 plus 15y equal to negative 32. Add 2 on both sides, and you get 15y equal to negative 30. Divide by 15, and y equals negative 2. Let's check the other side. 7 minus 5y is equal to 17. Subtract 7, and you get negative 5y equal to 10. Divide by negative 5, and you get y equal to negative 2. This checks out. They're both negative 2. So when we write our answer, it's 1, negative 2. So again, we're going to try this on the bottom. Now, negative 5 and 3, they don't really have a common multiple. There's not one that's a factor of the other. Well, they have a common multiple, but there's not one that's a factor of the other. They don't have a common denominator. But negative 2 and 6 do. What can I multiply negative 2 by to get opposite of a positive 6? I can multiply this top one by 3, because 3 times negative 2 is negative 6. Negative 6 is equal and opposite. Opposite meaning one's positive, one's negative, to a positive 6. So if I do that, I'm rewriting that top equation. I get negative 15x, because 3 times negative 5 is negative 15. Negative 6y, because 3 times negative 2 is negative 6, equals 12, because 4 times 3 is 12. And then we're going to rewrite the bottom equation. Okay, let's cancel out. So these cancel. Negative 15 plus 3 is a negative 12x. 12 plus 6 is 18. Okay, divide by negative 12, and you get x equal to negative 1.5. So now we're going to plug in negative 1.5 for x, and hopefully we'll get a y that works. Let's try this out. And sometimes you are going to get decimals. You just got to flow with it. I would suggest, especially if it's a finite decimal like this, to use a decimal. It might make your life a little bit easier. So we have negative 5 times negative 1.5 minus 2y equals 4. And we have 3 times negative 1.5 plus 6y equals 6. Negative 5 times negative 1.5 is a positive 7.5 minus 2y equal to 4. Subtract 7.5 on both sides, and I get negative 3.5 equals negative 2y. Divide by negative 2, and I get y equal to positive 1.75. Let's see what happens over here. 3 times negative 1.5 is negative 4.5 plus 6y equals 6. Add 4.5 on both sides, and I get 6y equals 10.5. Sorry, equals 10.5, not 10.4. Divide by 6. And we're going to double check this in Desmos because this one I can't do in my head. And hopefully, as you guys can see, I have still the graphing stuff up here. Hopefully 10.5 divided by 6 is 1.75. And it is. It's right there. It's 1.75. So this checks out. So our answer then, remember, is our x, negative 1.5, and then our y, 1.75. And sometimes it's just going to be decimals, and you just got to deal with it. Doesn't always help when it's decimals. I'm going to show you how I know this is true too. And you can always double check your answers in this. If we put this in here, negative 5x minus 2y equals 4, and our other one, 3x plus 6y equals 6, and I need to zoom in because I was way zoomed out. We can see our point of intersection. And again, remember, our point of intersection is where the solution lies. So this is the solution right here. And this point is negative 1.5, 1.75, which is what we found. So graphing is a great way to determine if you did the right thing. All right, on to the next page. Now, sometimes you're going to have to multiply both to make them equal and opposite. And it really just depends on if you want to do the x's or y's. Like, neither of these are factors of each other. So it's up to you. I'm going to do the x's, but you could do the y's. So I'm going to multiply this x by negative 4, because that's going to give me a negative 12. And I'll multiply this x by 3, because that's going to give me a positive 12. And a positive 12 and a negative 12 are equal and opposite. Instead, I could have multiplied this by 2 and this by negative 3. But since everything's positive, I do have to multiply one by a negative to get that opposite feature of equal and opposite. So negative 4 times 3 is a negative 12x. Negative 4 times 2 is minus 8y. Negative 4 times 1 is a negative 4. And here, 3 times 4 is 12x. 3 times 3 is 9y. And 3 times negative 2 is negative 6. So now we're going to cancel out. We're going to eliminate. Negative 8 plus 9 is just 1, so it's just y. And negative 4 plus negative 6 is a negative 10. So now we're going to plug that back into both equations to see if we come out okay. So 3x plus 2 times negative 10 equals 1. And 4x plus 3 times negative 10 equals negative 2. 3x minus 20, because 2 times negative 10 is a negative 20, equals 1. Add 20 on both sides, and I get 3x equals 21. Divide by 3, and x equals 7. Over here, 4x, 3 times negative 10 is negative 30, equals negative 2. Add 30 on both sides, and I get 4x equal to 28, because negative 2 plus 30 is 28. Divide by 4, and x equals 7. This checks out. So my solution is my x and then my y. So this is my solution. Okay. I want you to try and do the next one by yourself. It's okay. Try it. If you get stuck, it's okay. I'm going to go over it, but I just want you to try it yourself. So pause the video. All right. Because we already have one positive, one negative here, I'm going to multiply the y's. But you could have chosen to do the x's. You're going to get the same answer. So don't freak out if you chose to do the x's. But for the y's, I'm going to multiply the top by 2 and the bottom by 3, which will give me 4x plus 6y equal to negative 38. And then 9x, because 3 times 3 is 9. 3 times negative 2 is negative 6y equals negative 30. Cancel out, and I get 13x equal to negative 68. And I'm double checking that I did my math here correctly. Oh, I did not do something correctly. Hopefully, because something didn't look right. That's how I knew I didn't do something correctly. Hopefully you figured it out, but I didn't do 2 times 4. So I have to go back, and that's actually 8, which means 8 plus 9 is 17. And I knew I didn't do something correctly because that wasn't going to give me a number that I could work with. So now we're going to divide both sides by 17, and negative 68 divided by 17 is a negative 4. So we have x equals negative 4. Now we're going to plug negative 4 back in both times. And as you can see, like, I make mistakes too. It's okay if you make a mistake. Just go back and see what happened. It's no big deal. All right. 4 times negative 4 is negative 16 plus 3y equals negative 19. Add 16 to both sides. 3y equals negative 3. Divide by 3. And y equals negative 1. Over here, 3 times negative 4 is negative 12 minus 2y equals negative 10. Add 12. Negative 2y equals 2. Divide by negative 2. Y equals negative 1. It checks out. And my solution is negative 4, negative 1. Now, I'm going to tell you exactly how I knew I did something wrong. It's because I had 13 and negative 68. And I'm going to be real. I know that 68 can't be divided by 13 well. So if I put 68 divided by 13 in here, I get a really weird number. And generally, they're not, like, test makers, people are not going to give you something that it's that crazy, especially in Math 1 and somewhat in Math 2 too. They like integers. They like whole numbers typically. So that being said, I just knew that something was off. Okay. So now that we did that, now we're going to see if we can determine the number of solutions. So there's nothing that's equal and opposite to make these, and you only want to ever make the x's and y's equal and opposite. I don't care about these numbers. Don't worry about that. But to make the bottom equation x equal to this x but opposite, I'm going to multiply by negative 2. Because negative 2 times x gives me a negative 2x, and these are going to be equal and opposite. So I'm going to rewrite the first equation first. And then I'm going to write the new equation. So negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And negative 2 times 9 is negative 18. Well, these cancel out, and these cancel out, which means you get essentially 0 equal to 0. Guys, does 0 equal 0? Yes. So this is, again, we did this yesterday, but this is when you have infinite solutions. When everything cancels out, or when you get 0 equal to 0, it's infinite solutions. All right, let's look at the next one. I imagine you guys can see where this one's going. All right, well, none of these are equal and opposite, so to make it opposite, I need to multiply this top line by a negative 1, a negative 1. Because that'll make this a positive 2, and a positive 2 is opposite from a negative 2. So negative 1 times negative 2 is 2x. Negative 1 times a positive 5 is negative 5y. Negative 1 times 7 is negative 7. And then rewrite the bottom one. So again, I multiplied by a negative because none of these were opposite. They're all equal. To make it opposite, I need to get this to be positive. To get a negative 2 to be positive, I multiply by a negative 1. So these cancel out, and this gives me 5. Since nothing is left on the left side, we say it's 0. Guys, does 0 equal 5? No. 0 does not equal 5. So this is no solutions. So when your variables cancel out, but what it's equal to doesn't cancel out, it's considered no solutions. Okay, guys, thank you for bearing with me. You have a quizzes to do today, and then tomorrow you will have a Desmos activity, so no more videos. This is the last time you're going to be seeing me before spring break. So I hope you guys have a wonderful spring break. And if you need any help, know you can always email or do whatever you need to get in touch with me. Have a wonderful rest of your day, and I'll see you in a little while.